This video is the second part of our Mock 5 review, which are the rest of the questions, our review questions, so numbers 16 through 25. With this first question, we're looking at this graph here and seeing which statement is true about P of x. So as x approach negative infinity, so as we're going to the left, what direction is the left side of our end, or what's P of x approaching? Well, this is going down, but this says positive. So A is not our answer. Now let's take a look at B. B said that the function has a degree of 3 because there are 3 real zeros. Now, real meaning our total number of zeros, which includes multiplicity. So here we have 1, 2, 3, but how many total? This is a bounce with a multiplicity of 2. Slice is 1. Slice is 1. So notice how we actually have 4 total zeros. So this is actually a degree of 4. So B is not our answer. Now let's take a look at C. The degree is even. Well, both arrows are going the same direction, and we just said that the degree was 4. So that also matches. And a negative leading coefficient. Well, what direction are both arrows going? Down towards negative infinity. So before we say C is our answer, let's make sure that D is false. He says as x approaches positive infinity. So as we're now going to the right, looking at the right side of the graph, what direction is our graph approaching? Negative, but this says positive. So yes, C was the answer. Now question 17, this is asking, given the polynomial here, which of the following expressions represents a factor? Well, now, if you recall, when we're talking about a factor, when you divide by a factor, the remainder has to be what? 0. So this means we need to divide to see which is going to give you a remainder of 0. Notice how all of them, x is by itself, so I can just do synthetic division. I'm going to set this up as -8. You don't need a 0, so 8, -27, and -20. Now I'm going to go through using synthetic, bring always the first below, and then multiply. So -8 times 8, -64. Here I've got not 81, -91. Now I can already tell that this is going to be a negative times a negative, which is a positive 729. So that is not my answer because I need a remainder of 0. Now I'm going to go to B. Here, setting it up with +4, 8, -27, and -20. Bring down below your 8. Multiply to get 32. Add, you get 5. 4 times 5 is 20. Oop, there's your remainder of 0. So that means that's why here B is the answer. So now just to show you why C would not be the answer, here, set it up. So now you got +2, 8, -27, -20. Bring down 8. 2 times 8 is 16. Here you get -11. This is -22, which gives you a remainder of -42. And again, you need that remainder of 0 in order for it to be a factor. So that's why, again, B is the answer. Now, 18 is also here. You're given that a polynomial P of x is being divided by 2x minus 4. It says that the answer after dividing by 2x minus 4 can be expressed as some answer q of x, but with plus 5. Now, whenever we wrote our answer and we had this extra fraction here over what we divided by, what did this always represent? The remainder. So this is showing how we need a remainder. If we were to divide by 2x minus 4, that means what do we have to have a remainder of? 5. So which of these polynomials supports the student's claim? So which of these would you divide by 2x minus 4 and get a remainder of 5? So this is long division. So here I'm going to set it up, 2x minus 4, 8x squared, no need for a 0, no terms are missing, plus 3. And always divide first into the first. So 2 goes into 8 4 times with 1 less x. Now when you multiply, they will match up. So that's 8, but don't forget to multiply 4 to -4, which is -16x. Then before you combine, change the sign. So that's a negative and a positive. Now I've got 4x. Bring down 3. Now divide 2 into the new first term, which is 4. 2 goes into 4 2 times. 2 times 2 again, matching up. And 2 times -4, which is, so again, don't forget to multiply by -4, which is -8. Change the signs. Now notice you end up with a remainder of 11. So A is not our answer. Let's go to B. Again, setting it up. 2x minus 4, no 0 needed because no terms are missing. Same thing again, divide the first into the first. So 2 goes into 12 6 times, so 6x. When you multiply, they will match up, 12x squared, but multiply 6 to -4, which is -24x. Then change the signs. So that's 0. Now you have 14x. Bring down -20. Now divide new term into the new first term, 14. It goes into 14 7 times. So now when you multiply, that will match up, but 7 times also -4, which is -28. I can already tell I'm not going to get that remainder of 5 here because when you change the sign, you get 8. So B is not my answer. So now I'm going to go to C. So again, here, setting up division. Do we need a 0? No, no terms are missing. Divide the first term into the first term. 2 goes into 8 4 times, so 4x. So now when you multiply, they will match up. Don't forget to multiply 4 to -4, which is -16x. Then change the signs. So that's 0, -30 plus 16 is now -14x. Bring down 33. Now divide 2 into the new first term, which is -14, giving you -7. When you multiply, they will match up. Don't forget again to multiply -7 to -4, which is +28. Then change the sign. Now notice you do have 33 minus 28, which is 5. That's why the answer here is C. You needed a remainder of 5. If we were to write this answer, this would be 4x minus 5 plus 5 over 2x minus 4 to represent the remainder. Now 19 and 20, we're focusing again on the I operation. So here I've got to multiply by the conjugate, which is always change the sign of the imaginary part. So the conjugate in this case is 5 minus 4i. Change the sign of the imaginary part. So now we're going to multiply 4i to our numerator here, which is 20i minus 16i squared. But remember, I squared is always -1. Two negatives make a positive 16 plus 20i. So I notice I need both positive values. So I'm going to mark off B and D. And here, if you remember our shortcut in the end, we are always going to add after multiplying our two values together. So 5 times 5 is 25. 4 times 4 is 16. When you add them, you do get 41. That's why the answer is C. Then question 20. Notice how you're not just raising this power to a power, but you also have -9 to the third power. And -9 to the third power is -729. Then I here, power to a power. So what do? Remember parentheses, so we multiply. So it's now I to the 33rd power. Now we can focus on quarter method to simplify. Here I'm going to divide by 4 my exponent. So when you divide, you end up with 8.25, which is 1/4. So this is the same as negative 729, but now times I to the first power. Well, what's I to the first power? Just I. So our final answer is negative 729I. Then 21, this is a review on understanding the vocabulary here with degree, unique zeros, and real zeros. So here, degree, remember, is just another word for the exponent, where you're focusing on the degree here, where we add up all the exponents. Remember, this has an exponent of 1, 2, 1 plus 2, which makes a degree of 6. So then the total real zeros, our real zeros, if you recall, include multiplicity, which is our exponent. So this will always match up our degree. So from the fundamental theorem of algebra here, that's why here you also end up with 6 real zeros. However, how many unique or different zeros are there? Well, we have x is equal to -4, +1, 2, and 5. So there are only 4 unique zeros. Now, here in number 22, we're solving for x. I need to distribute x here. So we're going to now solve x squared minus 10x is equal to -30. However, because now we're solving a quadratic, it has to equal 0, so add 30 to both sides. Nothing can be combined, so we're going to solve x squared minus 10x plus 30, which is equal to 0. Now, there are no two factors that multiply to get 30 and add to get -10. I can also tell from my answer choices, I'm going to end up having to use here, because I can't factor, quadratic formula. Remember, quadratic formula is x is equal to -b plus or minus the square root of the discriminant, b squared minus 4ac all over 2a. Now, I'm going to focus on first getting the discriminant. So here the discriminant is b squared minus 4ac, so identifying my a, b, and c, -10 squared minus 4 times 1 times 30. That's 4 times a times c, which is 100 minus 120, giving you a discriminant of -20. That's why we need I in our answer, because the discriminant's negative and we have 2 imaginary. Now I'm going to continue. X is equal to -b. Well, what was our b? -10 plus or minus the square root of the discriminant -20 over 2 times 1. Now notice here 2 negatives making a positive. So I need positive here as the front value. So I'm going to mark off A and C because they're still both negative. Here I can also simplify the square root of 20. Now remember, do not divide. Always focus on the radical first here and simplify. So I can simplify the square root of -20 to, well, I know that that's 20 and -1 because the square root of -1 is I. So that's where our I comes in. Then here I've got the square root of 4 times the square root of 5. The square root of 4 is 2, so 2i radical 5. So I can rewrite this as 10 plus or minus 2i radical 5, all divided by 2. Now we can simplify, because here I can divide all 3 values by 2. 10 divided by 2 is 5, and 2 divided by 2 is 1, so 1i, or just I, radical 5. That's why the answer is B. Now 22, the second part. Here, I don't have an x term, so I only have the 2 terms. So this is when we treat it like a 2-step. So I'm going to rewrite this for space here to solve. And now I'm going to subtract 3 first from both sides. So subtracting 3, now I have 16x squared is now equal to -3. I cannot take the square root yet, because it's still being multiplied by 16. So now I'm going to divide by 16. Now I've got x squared is equal to, I cannot divide that, so let's leave it, -3 over 16. Now I can take the square root because x squared is by itself. I've got the square root here, which is the same as the square root of -3 over the square root of 16. Now, square root of -3, that's still the same as I, and then radical 3 over, well, the square root of 16 is plus or minus 4. So plus or minus, so that's why here the answer is C. Now, in these two questions, we're just factoring. So again, review with our bottoms up. So I'm just multiplying first to last. I've got x squared plus 10x plus 24. Then here, what two numbers multiply to get 24 and add to get 10? 6 and 4. But because you multiply by 3, that was your A, divide by 3. So now I've got x plus 2 times, bottoms up, 3x plus 4. Then here, I only have two terms. So I notice that this is the sum of two perfect squares, where I can take the square root, no GCF, but when it's the sum, we now do need I in the factored form. So square root of 4 is 2, so 2x, because the square root of x squared is x, plus the square root of 81, which is 9, so 9i, times 2x minus 9i. There was no GCF, so you can go right into with your two perfect squares here to factor. Question 24, using the table, which of these equations represents the function in standard form? So again, you need the zeros. And if you recall, whenever we're identifying the zeros, we always have x and then the y coordinate was 0. Or in this case, it would be your x and g of x. So g of x is 0. That's your y. That means -2, 0 is a factor, 1, 0 is a solution, a 0 a root, and 3, 0. Because 0, 6 is actually representing the y-intercept, so we don't need that. That means I'm going to cross off C and D because it includes that y-intercept. And then remember, when writing the equation, change the sign. So it's not x minus 2, but x plus 2, x minus 1, x minus 3. So that's why the answer is B. Last question, 25, we're selecting all that apply. Which statements are true about our polynomial graph here? As x approaches negative, so as we're going to the left, what direction is that left side of the graph approaching? Well, it's going up towards positive infinity. So this statement is true. The next statement says we have a positive leading coefficient. Well, read it left to right. And what direction are we going? We're going down. So this means it's not positive, but negative. So that's the second statement is false. The equation in factored form. Well, here they changed the sign to x plus 4 from x is equal to -4. However, that is a slice, which is a multiplicity of 1, and they put it at 2, and then they didn't even include the slice here, which is at -3, which would have been x plus 3. So I can already tell that the equation is also not correct. The degree of the function is 5. So remember, degree includes exponents, which is your multiplicity. So we have a slice here at 1, which is 1, slice, which is 1, slice, slice, and slice. So all 5 were a slice, making a degree of 5. And we also have an odd function here because the arrows are going opposite directions and 5 is odd. So it all matches up. So the degree is 5. Over the interval, -2, -1. So that's your x's. So we're looking at from -2 to -1. So we're looking at this portion of our graph. Well, Is it above or below? Well, it's above here. It's above in the positive, but this says that the values are negative. So this statement is false. Then end behavior for the last statement, as x approaches positive infinity, so as we're going to the right, what direction is the right side approaching? Well, it's going down to negative infinity. So this last statement is also true.